Okay, so we can write the polynomial functions in what's called a factored form. And when we do that, we have something like f of x equals a, and then we have x minus, and what we're going to have right here is x sub 1, and then to some p sub 1. And then I'll explain this a little bit more. And then, as many factors as we have. The x sub 1, x sub 2, etc., those are the x-intercepts. So each intercept makes a factor. So sometimes we have things that say, well, if you have an x-intercept of, I don't know, k, then x minus k is a factor. Okay, so that's a theorem we have. I don't remember seeing it in this book, but it's one that we have. The p sub 1, p sub 2, etc., those are the multiplicities. Now you may have noticed I snuck in this letter A. That A is the stretch factor. So back to transformations, we know we could have some multiple that we factor out that affects the graph, but it doesn't necessarily show up if we just put in the intercepts. Okay, so what they're going to do is they're going to give us a graph, and we're supposed to come up with the polynomial of least degree. Now, that's kind of important to say least degree because, sometimes when we look at the multiplicity, we might know it's odd, but we don't know if it's 3 or 5 or 7. So we're going to go with the lowest number. Okay. So it says write a formula for the polynomial function shown. Okay. So it looks like we have an intercept right here at -3, and one at 2, and one at 5. So then we know factors. Okay. F of x equals, now I'm going to put in that a, because we didn't talk about that much, but we will in this example. So I'm going to have x plus 3 is going to be a factor. Now you might be saying, well, how are you getting x plus 3? Remember, it's going to be x minus whatever the intercept is. So that's going to be x plus 3. Okay. And then we're going to have x minus 2, and we're going to have x minus 5. Now, I didn't do anything with the multiplicities, but we'll do that now. So it looks like it's crossing here pretty just straight across. So that's going to have a multiplicity of 1. I wouldn't normally write the 1. And then this is at 2, we're bouncing, right? So it's got to be even. So the least even number is going to be 2. And then we're crossing here as well, and so that's going to be a 1. So now I have my function saying f of x equals some a that we're going to have to figure out. And then the factors are going to be x plus 3, x minus 2 squared, and x minus 5. Now, how do we figure out what a is? Well, the easiest way is to find the y-intercept. So find the y-intercept right there, the y-intercept. And hopefully your graph will show the y-intercept. If it doesn't, you could pick another point that you know, but it shows us the y-intercept. So what it's saying is, it's saying f of 0, right? Because that point is 0, -2. So f of 0 is equal to a. And then we're going to put in 0 for x. We've done this before. So we're evaluating the function at 0. So I put all the zeros in. But we know what this equals. It equals, -2, right? Because we know if we evaluate at 0, it's going to be -2. This is what allows us to find a. All right, so now we have to do a little bit of work. We get a times 3 times -2 squared times -5 equaling -2. So that's going to be, let's see, 4 times 5 is 20. We're going to say that's negative 60. Whoops, a equals negative 2. And divide by negative 60. So we get a equals 1 over 30. Now we know the stretch factor, at least for this function. And so we can say, I have no place to write the equation. F of x equals 1 over 30. And then all those factors that we wrote with their multiplicities, or their exponents, I guess I should say. Okay, you don't have to multiply it out. You can just leave it in a factored form. Okay, so I thought if it were confusing, I would do another example. So we'll try another one. So we have x-intercepts at negative 1, 2, and 4. So our function is going to have factors of x plus 1, x minus 2, and x minus 4. And then what will those multiplicities be? Well, we're expecting this one to have the lowest degree would be 2. I mean, it could be a 4 or 6, but we're just going with a 2. And then we know this one's going to have a 3 because it's not just straight across. It's got that flattening out. So that's going to be the least degree there. And then finally, a 1 there. And the part we don't know is a. Okay, so we can find a, though. It looks like it's going through right here at negative 4, I'm going to say. So 0, negative 4. And so if I plug in a 0 for the function, f of 0, it's going to equal a times 0 plus 1 squared. I don't know why I keep writing the zeros in. For some reason, I think it's going to help make more sense. I don't know. And that's going to all equal negative 4 because when we evaluate at 0, we're getting negative 4. Okay, so now we get a times 1 squared times negative 2 cubed times negative 4. And then that's going to be, let's see, negative 8 times negative 4, it's going to be negative 32. A. Let me make sure I did my math right. Okay, so dividing by negative 32. They don't always come out to be fractions, but not too surprising. It's a fairly small graph. Okay, so I get like 1/8 there for a. So now I can write the function f of x equals 1/8, and then I just put in all my factors with their appropriate exponents. Okay, so hopefully that example helps. And there you go. Oops. And there it goes. Slide. I'm just trying to make my box better. Okay, and that's it.